Hello everyone. Um, as you already saw, my topic is about web components. I call it often the Lego bricks of web developers because you can use them everywhere. Um, yeah, as you already saw, my name is Czichon. I'm working in a small company in Germany as the head of software development, and we're developing a product called Edelog. It's like a framework for digitalization, and where you can help small companies moving to digitalization era with mostly in the machine industry. My focus is on Node.js and web components. Also, I'm doing a lot of contribution to the Ionic framework, which is a mobile application framework with web technologies. I'm one of the first contributors from 2014. Back in the history, I was a C# developer, but I moved quite early after my apprenticeship for informatics to the web technologies because Microsoft wasn't doing this open source stuff back in the days. And it's great to see at this conference that are many technologies are moving to the open source community, like the Java talk we saw before, like all these infrastructure topics are also moving to the open source community, which is pretty great. The basic problem of HTML elements is that we have a limited set of HTML elements. Everyone knows these heading tags with A1, 2, 3, 4, 5, and so on. The div spans, inputs, some of the new media queries like video, picture, audio tags, but they're also all limited to the specific set which is defined by the W3C. For example, if you want to build a login form. For a login form, you want you maybe want to reuse it in multiple applications. So if you have, for example, like we have in our product, we have one backend server, and this backend server serves multiple applications to our customers, which the customer can enable or disable. Every of these applications has an login form, and because they are working standalone. And so the problem was, if we want to reuse this login form, we have to create this login form for every applications. In the normal way, you're declaring some basic index HTML file and put something like this. And this is our login form. You can see it's like it looks like a card. It has some metadata like a login and a text. It accepts a username or email for input and a password and a button of the type submit. So that's a login form as we know from common web pages or web applications, for example. So we can also go to see something like this live, but I currently don't know how to move to the other desktop. Okay. I think I should do this like this. Yeah. You can see here, this is the application I showed in the presentation. And if we want to open up this application, we can open it. I have one of these new MacBook Pros which has keyboard issues. So that's our login form. Pretty common. We have it in multiple applications on the web. It's basic HTML. Everybody knows this. And now, for example, we want to use it in multiple applications like we wanted. And in this case, I've copied in the old ways the HTML template, copied to the new application, maybe changed a few things, and then I can use the same code. So, but what is, for example, if the CSS updates it? So we have the designers designed a new login form, and they want to reuse the classes and also added some new classes we need to add to the login form. So every application needs to update their HTML structure. These problems are already solved, for example, in most of the common frameworks like React, Angular, Vue.js. There you can write components, for example, a React component called login component, where you can put all the HTML inside, add some properties, and you can use this React component in every React application. Same for Angular. You can write an Angular component. Maybe you put it into a module so you can share it across your Angular applications, and then you can use it in every Angular application. Same for Vue.js. The problem with this is that you only can use these components inside these frameworks. So for example, I can't use that easily a React component in an Angular application, or otherwise using an Angular component inside a React application. Angular has a new function since September, I guess, where you can export with Angular elements an Angular component as a web component. But we're coming to this later. Sometimes you only want to have this component exported for your applications, or you only want to have one component which is usable in every framework, or even without a framework. And that's the point where web components come in. And web components are basically a set of web platform APIs where you can create custom HTML tags which are reusable and encapsulated. So these components have its own context for only this HTML tag. For example, we have a login form. All the logic and all the handling belongs to this component and will be handled inside the component. So web components are not a specification itself. It's more a set of specifications. For example, we have the custom elements, the HTML imports, shadow DOM, and HTML template. And all these together are called the web platform APIs. And with these four platforms, I can build a web component. Here you can see HTML importance. They're no longer part of these specifications. As introduced, the HTML imports was a method where you can import HTML templates, also .html files, like you can import script files in the web environment. This was sometimes implemented in Chrome in some versions behind flags, but as the introduction of ES modules, they removed the HTML imports from the specification, and also Chrome removed the HTML imports from their implementations in the current versions. So as we have now ES modules, we can solve this problem with ES modules. For example, if we want to create a new custom element, like a Star Wars character, for example, we first define the name of the component. In custom elements, we always have to define the components with dashes between the words, so we can separate them from the normal HTML text. So normal HTML text haven't any dashes inside, so if you see on the web some components with dashes inside, they are mostly web components or something else from other frameworks. Then we have to pass them a ES6 class, and optional we can extend existing HTML element, for example the paragraph, or for example the div, or a heading, or something else. To implement these custom elements, we create a new class, for example the Star Wars character, extending the HTML paragraph element. So we also have all these methods and properties from the HTML paragraph, call the constructor from the HTML paragraph element, and that's it. So where you can see here the element implementation, you can now put here your logic for your custom element. Next part is the shadow DOM. And the shadow DOM has a larger story behind it because it's not that new. Currently, because Chrome already implemented it for a year ago. I don't know what's going on with the protector, but we continue. And it's pretty hard to understand. Normally, if you have a rendered HTML file, the browser always renders your HTML DOM once. And as soon as you update some value inside your HTML DOM, the browser re-renders the complete HTML DOM. So if you have a large application with multiple updates on the DOM, it always re-renders the HTML DOM multiple times. I don't know. And I don't know what's going on. And so the idea behind the shadow DOM is that the element itself is creating its own DOM environment, for example. It's called the shadow tree in this case. And this shadow tree always has an shadow host element, which, for example, could be a div or a paragraph or one of these default HTML elements. And the shadow host is the hosting element for this virtual tree. If you're a React developer, you already noticed something like it's called virtual DOM. And the shadow DOM is the native implementation for this. And so if something updates inside the component, so your component is, for example, a heading, a label, and an input box. And these are rendered inside the shadow tree. And as soon as you update the input or the label, it only re-renders the shadow tree and not the complete the complete HTML document, which increases the performance. To create a shadow DOM inside your custom element, you simply can call the element reference, attach shadow DOM, and optionally you can add a mode for it. It's called open or closed. Open means that you can access the shadow DOM through JavaScript. For example, if you need to do some DOM manipulations inside the web component via JavaScript, or you can say it's closed, so it's really hard encapsulated and isn't accessible through JavaScript from the other application. Then you can create the inner elements, for example, the heading tag, append it as a child to the shadow DOM, and that's it. Next was HTML imports. This is what I've called before, the importing HTML templates like a normal link attribute, but this is no longer relevant. For this, we have now the ES modules, where you can import a JavaScript file as a module, like you maybe know it already from TypeScript or from Angular is using TypeScript also, and maybe, for example, the new syntax in Node 10, I guess, or 12. And so you can also use these imports natively in the browser now. HTML templates. This is also a new specification of the Web Component standard. You can define templates inside your HTML document. For example, starting with the template and then giving it an ID. In this case, SV character component. And put, for example, some content in there and the closing template tag. So the benefit of this is until you use this template, it's not rendered inside the DOM. So you can copy a really large template into your index HTML, for example, but it will not be rendered until you're enabling it through a web component. If you want to enable it, you need to do this via JavaScript, getting the element from the document, cloning it as a new DOM node, and then appending it to the body. You can also not appending it directly to the body, for example, to a shadow DOM. This is also working. And if you combine these three things together, you have the class, the ES6 class, called SV character, where you read the template from the HTML, cloning it, adding it to the shadow DOM, and define it as a custom element, and now you can use it SV character component inside your HTML. And this is how the markup looks like. Here you have the template ID, the template we are using, and here you can see the component, how it's used. Let's talk about browser support. Well, this situation is way better now than half a year ago. For example, HTML templates are supported in all major browsers. Well, Internet Explorer is not relevant anymore. Maybe you're working in a large company, enterprise company, where still using Internet Explorer. Many of our customers using Internet Explorer. What we're doing in this situation is mostly bundling our application as an Electron app, which is based on Chromium, so we can ship it as a native application for our customers. So HTML templates are supported in nearly every browser. Custom elements are currently also supported in many browsers, not in Edge currently. It will be supported in a future version of Edge, especially as they're moving to the Chromium base, and there are some issues with Safari because Apple don't care about new web technologies. Shadow DOM is also way more better than a year ago or half a year ago. It's now supported in all major browsers, also in Safari with some properties which are not supported, but mainly it is supported widely. And HTML imports are no longer supported because also Google Chrome removed them and the W3C removed it from the specification because we have ES modules. I haven't listed ES modules here because they're supported in every browser currently, except EA. For all the other browsers which are not supported, there are existing polyfills. You can add support with polyfills, so there's a package called Web Component on webcomponents.org. You can also find there some samples and some open source web components which were built based on the main specification of web components. And the downside of web polyfills are always that I need more bandwidth to load this extra library. Good thing is, also for web components, there are existing libraries where you can build easily web components, so you don't have to do anything from scratch. For example, there's our mostly Google-driven framework called Polymer. Then from the Ionic guys, it's Stencil.js. It's more like a transpiler for web components than a framework. And there is Skate.js, for example, with Preact or lit.html. Also, you can use lit element, as maybe if you heard the talk yesterday about lit element. So we're skipping lit element for today. We're making the demo later with the Stencil.js. For example, this is an image. You don't have to read this code, but it's a comparison of all the libraries which are supporting web components. And for example, you can see here on the left, this is a native web component written only with the specification. And then you can see, for example, if you use Angular Elements or Skate.js or Stencil, you don't have to write this much code for a simple web component. So what about our login component? So for this, we could move to the editor back. Well, I need to clone this so I can see it on my screen. Is there mirror displays? Okay, that's better. Okay, so for demo, maybe I should theme. Yeah, I'm switching to the light one. So this should be better. Okay, for the demo, I'm creating a new component. I'm switching to the stencil folder, and if you have installed the latest npm version, you can just use npm for a guided version of the stencil component. So npm init, and then stencil, and now the stencil set is asking you what you want to create. You can create an Ionic PWA. For example, if you want to develop a mobile first application, which is also working offline and looks like a native application with stencil. You can create a web application, which also includes the stencil routing, but you don't need all of these things if you want to simply create a component. So we want to create a component here. We call it dev 2019. And now it's installing all the packages. And we're going into the folder, run yarn start. And I need to switch to the Chrome. Yeah. Why is it not working? Okay, it's currently not working. I don't know why. Okay, I don't know why it's not working, but we can. I have prepared some other demo version. So yarn start. So here you can see this is a small web component from Stencil, the initial web component. And if you go to the code, you can see you have an index.html, which is just importing the JavaScript, the component file itself, and calling the component, which is generated by default, and passing two first arguments, the first and the last. And the component itself, it's an TSX file, as you may know from React with TypeScript, and you can see here it's the class from TypeScript is exported as a component, which defines which tells the stencil compiler, hey, this is a component itself. Please use it and compile it to a web component. I don't know what's wrong with the cables. Okay, and the stencil compiler was initially developed from the Ionic team for their own needs. So they've developed Ionic 1, which was an web framework based on AngularJS. AngularJS was released in 2009, and they want to build an web-first framework. Web-first framework where they can build mobile applications for Android and iOS and Windows Phone and the web. And at the beginning, in the first alpha of Ionic, they said they want to support multiple frameworks. At this time, they only supported AngularJS, and they continued developing and only supported AngularJS, and they dropped all the support for other frameworks. And then back with the new technologies, with web components, with PWAs, they said, okay, we're developing Ionic 4, which is based only on web components. So the current version of Ionic is based on their own web component compiler, Stencil, and there are native web components, so you can use the Ionic framework with every framework or plain JS for building mobile applications. So this compiler is production ready, you can say, because one of the largest mobile frameworks for web development is built with it. Okay, and As you can see, you have here these two properties we've already saw in the component, last and first, and all these properties which you have to add to your custom element by hand if you want to develop a custom element with the specification. Instead, you can simply use the decorator, for example, with add prop, and render the template like you do it in Preact or lit HTML or in React. Okay, so if we now want to create our own component, like the login form, we can rename it, for example. I don't know where is this. Okay, I need to read it here. Login form. Login form. And of course the component itself. Login form. Okay. I will call it login form and where? Oh, sorry. As you can see here, it also has at the component decorator a property called shadow. This is for components where you can enable or disable the shadow DOM, because shadow DOM is the main feature of web components where are the reason for this encapsulation. So every shadow DOM has its own CSS and stylings, for example. As you can see here, it's the login form CSS, and if I enable the shadow DOM like here, I can import an CSS file on the index.html, but it does not apply to the component itself because it is encapsulated. If I disable the shadow DOM, the component will be rendered into the default HTML DOM and all the stylings will be applied to them. This is a good way also for developers and designers working together on a component library and design system. For example, if you have designers and developers working together on a UI library, they can create design especially for one component, for example, for a button or for input box or something like this. Unable to load. Okay. So I'm going to remove the property so we have an empty class here. And copying our login template, which we want to use as a component. So I'm moving this and adding this. I don't know if... Oh, sorry. So, okay. I don't know. Oh, because it's importing property, but no longer using. Okay. And now you... sorry, this... Whoa. What was this? I don't know why it's not working. Okay. I don't know. I'm switching to the demo version. Yarn start. Okay, and this is our component inside the demo application. And as you can see here, it's this one. I've added the same HTML to the web component itself, and the web component itself now need to use the stencil function. So I created two state properties in this case using username and password, so every component can have its own state. And in this state there can be stored values like you have on a normal HTML tag. Often you have some property called value. And in a web component you can define multiple properties for values, for example like username and password. And I also defined an event which triggers an event to the other HTML DOM. So I subscribe to the unsubmit for the complete login form. I binding the username to the username field and the password to the password field, and always on the input as I type username or password, I'm updating the value itself, like using event target.value. And if I'm now submitting the form with the submit button and the unsubmit event is triggered, I'm calling the login emit event, which is triggering the event to the other HTML DOM. So I can subscribe me in JavaScript to the HTML event from the to the DOM event from the custom element. So if we switch to the index.html, we have now here our login form. I've gave it the ID 1. You can name it otherwise, but it's only this custom element login minus form. So this is our web component we can use in every application. And I'm creating a script tag like in plain JavaScript, getting the element, adding an event listener to the login event, receiving the data and log it to the console. So I'm subscribing to the login event which I've created here, and you need to remember that it's the same name like you name it inside your TSX class. So if I'm now open up the console, enter some data, you can see it's logging the login data to the console. And now you can combine multiple web components to a web application, for example. Stencil also provides a router where you can use the router, for example, to for creating large applications or Ionic PWA. This web component can export it to, for example, npm, and then you can reuse it in your application. So I'm switching back to the presentation, and that's how we're using it now in Edilog. And before our application was designed, like we have a plain.js idle core, which handles the most of our business logic. We have a Vue.js application, which has most of the client logic inside, and then we created an stencil web component library called idle elements, which is a UI component library. And we are using this UI component library in every of our applications, which is using the Edilog core framework, for example with React, Vue, Angular, and we have the same design on every application. The next step we are approaching is to move more logical things to the web components. For example, login and register. Building a login and register web component makes it easier to implement it in every applications, like admin application, system application. We even have a system called Edilog Classic, which was built on Angular 2 alpha or beta or something like this, with a Ruby backend. And we also can create a new login and register screen for the old Edilog Classic version, because we can simply exchange these Angular components with web components. We are also trying to open source the Edilog framework. at the end of this year. Edel Elements is already open source. You can install the npm package already, and yeah, that's it so far. Any questions?